Hi, so my name is Evelyn Wright, and I have the water hyacinth, and it is native to the tropical South America, so Brazil and Venezuela. It belongs to the Plantae kingdom and the Anthrophyta phylum. One of its niches is it filters by absorbing excess nutrients, and then it also improves quality of water and limits growth of algae. Some limiting factors in its native habitat is that it does have a water range. It cannot be in prolonged cold water or temperature above 33 degrees Celsius. Its optimal temp is between 28 and 30 degrees Celsius. Um, and due to this water temperature, it does have location limiting factors. So it can't be anywhere with too cold water because it won't grow. And then it has needs for nutrients. So nutrient availability, if the water is deficient in nitrogen and phosphorus and has too high pH levels, that also limits its growth. And then light intensity because it is a plant and it does need light to grow. And then some invasive areas is southeastern United States, so Georgia, Louisiana, Mississippi, Alabama, Tennessee. It's also in California, the Great Lakes, and just along the coastal Northeast. And then around the world, it's in tropical regions such as Asia, Africa, Australia, and New Zealand. They spread asexually and by fragmentation. Also, sexual reproduction by seeds because it does produce seeds, and then the water carries the seeds down the stream by like the wind and the rapid and just the flow of the water. And so then that's how it spreads down the water, and then it can double its population size in 2 to 3 weeks. It can double, so it's continuously rapid spread. It can double 2 to 3 weeks. New total double population. And then some impacts that it has is it does create a dense mat that covers the surface of the water, and that blocks light. And then it increases or it decreases biodiversity because it outcompetes other native plants for resources. And then because it does grow so rapidly, the other plants don't stand a chance against them. And then it decreases water quality by rotting plant material. Dead plants sink to the bottom, and so those stay there and they rot, and that decreases the water quality. It decreases oxygen because it blocks and clogs the surface, and that lowers the levels of dissolved oxygen in the water. And then the changes in niche and behavior. So it can now inhabit rivers, lakes, canals, and reservoirs where before it couldn't. It has adapted to colder water and winter temperatures, so it has created a wider temperature tolerance and now can sustain itself in colder waters. It does change the movement of wading birds because they avoid areas with high density because the mat blocks the surface, and so they can't dive in and access the fish. So those birds do avoid those areas, so it changes their movement patterns. It does in the dense areas replace the native vegetation that's in the that was already there before it, because it does outcompete all the other vegetation. So it does replace those vegetations, and then also they have developed thicker and larger leaves. Some controls and solutions is harvesters, which is like mechanical machines. They scoop up the large amount of mats, and then, however, it is not labor efficient, and it needs to be done every 2 weeks because, again, it is rapid reproducing, so it's very labor intensive. That you can use herbicides, which kills large amounts and is cost effective. However, it's harmful to fish because of the oxygen depletion of the dead plants, because they do, again, just sink in the water, and that creates problems with clean drinking water available to the people. And then there's biological controls by insects, which is the most successful long-term solution. So the insects are brought up from southeastern U.S., but it can be difficult because it takes years to build up the insect population, and the weather conditions do kill the insects, and because the insects eat off the leaves, and so it kills the plants that way. And then habitat management. So if you just reduce the nutrients in the water, such as nitrogen and phosphorus, then they can't live because they need to be in nutrient-dense waters.